Today, let's look at an example of Python NoSQL processing with MongoDB. In MongoDB, JSON, or the JavaScript object notation, is the native language. So in this example, you're going to see data in the JSON format, as well as statements and expressions in JSON notation. The data set we're going to use is a data set about university statistics. So it's a list of universities with some basic information, ranking, and so forth. So here's an example, one record from the list. It comes with different types of data, integers, bool values, strings, and information such as the city of the university, the name of the university, the state, the enrollment, the website, and so forth. So to deal with MongoDB, we need to use the PyMongo module. Also, to be able to access JSON data, we need a JSON module. So that's import JSON and PyMongo. Now first, we need to connect to the MongoDB. And for now, we are going to connect locally to the local MongoDB server on the same computer here, and then switch to a database such as education. And supposedly in the education database, we are going to have a collection called schools. And that's what we are going to do here. So we establish a connection to the Mongo client, which by default will connect to the local MongoDB server. And then we switch to the .education, which is the education database. And this becomes the DB. And then within that database, we're going to point to the schools collection. Okay, so from now on, the schools variable becomes the schools collection in the educational database on the local MongoDB server. Now, just to make sure we have an empty collection, we first want to delete all documents in the schools collection. So what we do first is to point to the schools variable dot delete many using this particular statement here to delete documents. Now, within this delete many operator or method, we provide a parameter here with a pair of curly braces. We know in JSON, a pair of curly braces indicates an object. But because here we do not provide anything in the pair, that means this is an empty object. And so if you provide an empty JSON object to the delete many, that means you're going to delete anything, everything without condition. Okay, so supposedly this would remove all documents existing in the collection. And of course, for now, we do not have any documents in the collection, so it's going to remove non-documents. But suppose you have millions or even billions of documents in there, all will be gone at this point. Now let's load data from the JSON file. We open the school info.json with all the list of universities. Supposedly, it is under the data directory. So we use data slash school info.json, and we open the file as f. Okay, and so the next step is that we can read from the file. Okay, f.read is going to read the entire content, all the universities, the entire list of universities from the JSON file. And then we call the JSON.loads method to actually parse the data into the JSON structure. And so now when we assign this data to JSON, to the data variable now has all the university data, the list of schools. Okay, and so at this point, we can create a for loop to go through every school in the data, and each one we take it as a school. So the school variable is one university at a time in the data. And so we're going to take each university, which again is in a JSON format, and we're going to call the schools variable, which is the collection in the MongoDB. Dot insert one is going to call the insert method to insert one record at a time. Now, because in MongoDB, JSON is native, so we know that the school variable here is a JSON object. So we can use it directly to insert into the collection, into the database. Okay, so we do not need any format change here. We take the JSON object and we insert that object into the schools collection because JSON is native in MongoDB. Now here, of course, we have a count here. Every time we insert one new school, we add one to the count. So in the end, we can print how many schools or documents have been inserted into the database. And looks like there are 311 documents or schools in the collection. So let's try to find a document in a collection. And so a method that we can use is find_1 to just find one document, the first document in the collection. So again, the collection is the schools collection. Find one without any parameter here. In the pair parentheses, we provide nothing. That means we're going to find everything. But because find one only will return the first one, so this is going to return the first document of the entire collection. Okay, so we know this has already been some data in there, which is good. So in Princeton University, and so this is looks like the data are there. Let's do something more. So let's find all documents or schools in the collection and show their names. Okay, we can use this schools. Again, schools is a collection. The find is going to find all the documents. Again, without any parameter, without any condition, we're going to find all documents in there. But just so that we can show the schools here, we want to limit the list of schools to 25. So we can use this limit method to limit the entire list to the first 25. And then we can use a for loop to go through every document or every school at a time and show its display name. Okay, so again, I want to go back to the data that you encountered earlier, and you will see that there is actually this display name, the Princeton University. Okay, so for each school in the collection, there is this display name field that you can use. And so that's what we do here using the doc and then square bracket display name, which is to access the display name field of the document object for that university. And so here basically we show the list of names of the first 25 universities in the collection. Now let's use a more specific query, such as if we want to find all the schools in the collection from the city of Philadelphia in Pennsylvania. Okay, so we can create a query for the purpose. And so again, when we create a query, because the language in MongoDB should be in the JSON format. So let's create a JSON object for the query. So you see that here we have a pair of curly braces to create a query object. And then of course in the object you're going to see a set of key value pairs. Now we know our query is about the state of PA and the city of Philadelphia. And so let's put state, PA, city, Philadelphia in the query object. and then we use the query. So this is assigned to the query object, and then the query is used as the parameter for the school.find to find schools meeting this particular condition. Okay, and so the retrieved documents would then be assigned to PA underscore schools. So in this case, the PA underscore schools will contain all schools in PA and with the city equal to Philadelphia. Okay, and we're going to show the school information here. So in the result, we have found 3 schools in there. They're all from the city of Philadelphia, city of Philadelphia, right? City of Philadelphia. And the first university is the University of Pennsylvania. And the second is Drexel University. And then the third is Temple University. So these are indeed the 3 schools in Philadelphia. Now, perhaps you think this is the display, the output is too messy. There's too much information. We only want to look at a few fields and just get a sense of what they are and their ranking and perhaps their enrollment. So suppose we're interested only in 3 fields: display name, ranking, enrollment. So we can continue to use the same query. So we use the same query here. And again, we use the schools.find, the method, with the same query. But now we provide some additional parameter. So again, in this pair of parentheses, the first parameter is a query. Okay. And then the second parameter can provide additional information about what you are going to return, what columns in particular we are interested in the result. Okay, and so the 2 parameters are separated by a comma. And in the second parameter, as you can see, it's another JSON object in the pair of curly braces. And here the key and values mean what fields you want to show and what fields you want to hide. So when you put a 0, that means we are going to hide this particular field. So we are not going to show the ID, but we are going to show the name, the ranking, and the enrollment of the university. And so that's what we get in the result. We have the enrollment, we have the ranking, we have the name of the university. So this looks easier to see. Now, we have the information of 3 schools from Philadelphia. Perhaps we want to sort them in a particular order, such as the descending order of enrollment. We want to see which schools has the biggest number of students and which one has less. Okay, so we can do is that, again, we use the same query, and for the second parameter, we just change a way of expressing it. So we put this query, this JSON expression with information about which fields we want to show, which fields we want to hide, and assign this expression to fields. So this becomes the second argument. Okay, so this statement here will return, with this find method, will return the same universities, the same 3 universities in Philadelphia. But this find method is followed by a sort method, okay, to sort the outcome, to sort the retrieved documents from MongoDB. So what we do here is to sort by the enrollment number. And when you have a -1 here, that indicates is in the negative order, which is the descending order. Okay, so what we are going to see is we are going to see the same 3 universities, but in a descending order in terms of enrollment. Okay, so Temple University, because it has a large number of students, will be listed first. In MongoDB, there is also a powerful feature to aggregate. For example, you can put data in different groups and run statistics within each group. So this kind of aggregate function is very useful for data analytics and filtering. In the aggregate function, you can not only use one operation, but you can actually apply a series of operations to the data. And that's why the parameter here is called a pipeline, because you can have more than one operations that you perform one after another. Okay, but in this first example, I'm only showing you one operation in the pipeline, which is a $group operation. Now, because the pipeline can have multiple things, multiple operators in it, we have a pair of square brackets. And as you know, in JSON, a pair of square brackets indicates a list of things, okay? Even though here we only have one operation, which is the $group. Whenever you see a dollar something in MongoDB, it indicates this is an operator. It's some special function that you can perform on the data. So $group here is going to group the data by certain identifiers or an ID. So here, for example, perhaps we want to group the data by state and count how many schools in each state in the collection. Okay, so here we can say underscore ID $state. So this is going to group by, this is equivalent to, if you are familiar with SQL or SQL, this is similar to group by state. And then after you do the group by, then you can actually perform what kind of statistics you want to run for each group. And so here we want to do a basic count of the number of schools in each group, in each state. So we have this count field, which is based on a $sum operator. And so the sum operator is going to do for each individual record or document from the MongoDB collection is to add one at a time to the count. Okay, so if you add one for each record, this is essentially to count the number of records. Okay, so that's why this is called count, even though we are using a sum operator. So in the end, the result of this is going to create a group for each state and count the number of schools in it. Okay, so we have the table MV and the count is 2. We have another one, NY 21. Okay, so New York, and it doesn't make sense because New York has more schools in this collection. We can do something even more. As I mentioned, the aggregate function allows a pipeline of actions or operations to be performed. And so in addition to the group, we can also add other things to do a bit more about what's in the data. So first of all, in addition to count, we can also do a sum. For example, we also want to sum the total number of students from all the schools in the state. Okay, so we can do a $sum enrollment. This is going to sum the total enrollment of the schools. We can do some kind of average $AVG tuition to calculate the average tuition within that state. Again, this group by is based on the state as the ID. Okay, so this is going to complete a group aggregate and compute all the statistics. After this is done, this is only one kind of the first operation in the pipeline, you see actually we have a second in the pipeline, which is to sort. Okay, so $sort is the sort operation. And here we are going to sort the records by its count. And again, a negative number indicates we are going to sort the records in the descending order. So we are going to sort in terms of the number of schools starting from the state with the highest number of schools. And then we are going to limit. So this is the third operation, which is $limit. So in the end, we're going to limit the number of records to 10. In this case, we're limiting the number of states to 10. So we're only going to show the top 10 states in terms of the number of schools in the data set. Okay, so in the end, what we get after we have performed the entire pipeline, we're going to see CA has the most schools, 27 schools, universities in the collection, ranked number 1 here, followed by Texas, New York, MA, Ohio, and PA. Just a few words on the pipeline. As I said, a pipeline is a series of operators to filter or transform data. And there are a lot more you can do than I have presented. For example, you can use match to filter documents. And as you see, group, with $group, you can group documents by an ID and to run the statistics such as average, sum, mean, max. Sometimes unwind is also useful if you have an embedded structure. So for example, inside each document, you may also have a list of things. So unwind will allow you to kind of unpack the values so that you can also run statistics on them. The sort can sort documents by one or more fields. $skip can skip over documents in the pipeline. $limit will restrict the number of documents in the pipeline. You can use expressions such as sum, average, mean, and max to compute some of the statistics. Sometimes you also can collect values along the way in the group. For example, if you have values you want to collect, you can use this $@toSet to return an array of all distinct values for certain field in that group. You can also combine expressions and values using operators such as the Boolean operators and or not. Again, the pipeline is a very powerful mechanism in MongoDB that allows you to filter and transform data from one process to another. And in the end, you may be able to identify important patterns and interesting insight from the data.